One of the advantages of using the kit component feature is that values can automatically be placed for you in the input field. This is accomplished by making use of the equation editor. The goal is to automatically generate input values when your item is used in the list. Let's go back over to the profile, and here we have our roof decking with roofing kit. But to see how this works better with the equation editor, let's go to this top rail kit. Here we've created a deck top rail kit that populates bottom rail, screws, rail cap, and rail pickets every time we call the top rail for our deck. And we're going to use these four to understand how better to make use of the equation editor. There are four different ways you can make use of the equation editor. One would be to leave the item blank. Two, set a specific value. Three, reference a parent value. And four, build an equation. First, I can choose to leave an item blank. This means, for example, that if I don't want deck bottom rail to have a value inputted for me automatically, and I just want it to be blank, then I would just leave the equation editor blank, which is what we have here for deck bottom rail currently. So I'll leave it alone. Secondly, I can choose to set a specific value. Let's say in my business that whenever I call deck rail, I want to ship 2 5-pound boxes of deck screws. So in this case, I come to the equation editor and I type in the number 2. This means that anytime that I call this kit, I will get 2 boxes of deck screws regardless of the length of the deck rail. So a specific value is the same every time regardless of the entry that's made in the parent item. Third, I can choose to reference a parent value. Let's say for this deck rail cap, I wanted to match the inputs that were made in the parent item of top rail. So we'll open this component. The important thing to remember when you are building an equation is to reference what units are being expected in this component item. As we look to the top right corner, we see that for deck rail cap, QL or quantity length input structure is expected for this item. So we'll come down here and we'll choose the QL button because when we enter QL in the equation editor, it references the quantity length value from the parent. But let's say that we entered this wrong, that we were thinking that I just want the lineal footage from the parent. And while that's an acceptable value to make, let's see what happens if we go over to the list and try to use it. So here in the exterior deck pack, we'll come down to deck top rail and we'll make use of this kit that we've just been editing. We'll enter 4 8-footers, and now notice how deck rail cap came in. It came in with the total lineal footage, 32, because that's the lineal footage that was coming from the parent. But we also see that there's a warning symbol and the text is in red, indicating that that format, 32, is not the right entry format for an SQL formula. Instead, it should be in quantity length form. So we'll zero out this use of this kit, and let's go back to the profile and we'll fix it the way that it should be. Back in the profile, we'll open that item again, and instead of using LF, the lineal footage of the parent, instead we'll use QL, which references the quantity length list from the parent item. So next time we make use of it, we'll get an appropriate quantity length list. Finally, the fourth way that you can make use of the equation editor is to build an equation. Let's come to these deck rail pickets. And let's say that we want to ship 3 pickets for every lineal footage of deck rail. We note up in the upper right hand corner that the formula type is expecting a count as its input. So we want to generate a specific count of items. So we'll come to the lineal footage or LF button, and now we're referencing the lineal footage from the parent item. So in order to get our correct value, we'll need to multiply that lineal footage by 3. So we have 3 pickets for every lineal foot of deck rail. Now we could take this further and do even more with this equation. Let's say, for some funny reason, we want to multiply that lineal footage by 3, but then we want to divide it, that value, by the number 45. So we could put parentheses around this initial equation of LF times 3 and divide it by 45. And we could take that even further and put parentheses around that and take that value and multiply that by the count of the parent item. Now, there's not any good reason to do this in this particular case, but I wanted you to see how flexible you could be in building your different equations. And if you click on this FX button, you'll see alternate functions that you can make use of as you build your equation. Min-max statements, true-false statements, floors, ceilings, rounds, and so on. But let's come back to this now and simplify this and put it back to our original equation of the lineal footage of the parent item times 3. And we'll click OK. So now we can see the various different ways that we can make use of the equation editor. But once again, let's return over to the project and let's see how this works out. So here we'll pick our deck top rail. We'll make an entry of 4 8-footers, and we'll see how this populates in our list. Notice deck bottom rail has no entry. Deck screws has the value of 2 since we explicitly wanted that specific value. The deck rail cap is matching the parent item since that's what we specifically asked it to do, to match the QL list from the parent. And finally, the deck rail pickets is the lineal footage multiplied by 3, resulting in an entry of 96, which results in the correct count for our deck pickets. And we should also note that if you click the function button next to any of your kit components, you can make changes and adjustments to that equation for that specific place in the project, but it won't affect your profile settings. So by using the equation editor with a kit component, you can streamline your takeoff process.